Good morning. We are going to start by going over the homework question, and then I'm going to go into the another type of word problem that we're going to be looking at. Okay, so with number 12, you should have gotten 37 for the magnitude. So I'm going to show you how. We need to do the law of cosines. Okay, so we're going to do x squared. Actually, that's not going to be enough room. Maybe if I zoom in, I can. All right, so x squared equals. So we're trying to find this length, how long this vector is, okay? Now notice I had to find this 65 first, okay? So the angle that I give you in the problem, this 115, you're not actually using in the formula at all. It's helping you to find the missing angle beside it, okay? Because if you look at this triangle here, let's highlight it. If you're looking at this triangle, do you see the 115 is not in the triangle? It's outside of the triangle. So we have to use the 115 to help us find what's inside. And so we do 180, just to be clear, 180 minus 115 to get that angle, okay? Because of the linear pair. All right, so now we're going to do the law of cosines, okay? So we're going to do 24 squared plus 40 squared minus 2 times those two numbers, and then, sorry, I'm running out of room, cosine 65. All right, and we're going to type that right in. So 24 squared plus 40 squared minus 2 times those numbers, and then cosine 65, and you get a pretty large number. So you get x squared is approximately 1,364.57. Okay, but that's x squared. We want just x. So we take the square root, and x is approximately 36.9, which is about 37 degrees. Okay? Oh, I said degrees, excuse me. That's units. Now, that is our magnitude. That's the length, okay? Now we want to try to figure out this angle right here, how much that angle opens up. So if we're trying to find the angle, we're going to do law of sines still, but we're going to do, to find an angle, we're going to use these two numbers first, okay? So the numbers on either side of that angle. So do you see if you mess up the first step, it's going to mess you up here. So we want to be really careful that we get that first step correct. All right, and then we'll subtract the angle that's the side, across from the angle. So we want to put that in parentheses, and then 2 times the first two numbers, the ones that are on either side. All right, so then you should get a decimal when you do this, so let's type it in. And you get 0.19425, blah, 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 blah. And then you're going to do second cosine of that answer. The second cosine negative, second negative, helps you get that answer. If you have a handheld calculator, if not, you can just retype the number. And then theta is approximately 78.7, which rounds to 79 degrees. Okay, so our final answer is 37 units at 79 degrees. Okay. All right, let's look at a couple more types of problems. Okay, I'm going to do 2 with you that have pictures, and then you're going to do the remaining 3. All right, so this is, instead of forces working in different directions, this is going to be forces working on one object and the kind of going towards the object. So like if 2 people were pushing on a box, or something of that nature. Okay, so we have 2 forces here, one with a magnitude of 20 pounds and one with a magnitude of 14 pounds, and an angle of 55 degrees between them. Okay, find the magnitude of the resultant. Now notice, I'm only asking you for the magnitude here, and that's because it's going to be really hard to figure out the angle compared to the horizontal, so we're just not going to do it. So we're just going to find the magnitude. So that means we're just going to do the law of cosine where we're finding the side. So I want you to look at the picture, and I want you to ask yourself, are these two vectors tip to tail? And the answer is no, they're tail to tail, right? So they're both, pointing towards the same thing. So that means we need to slide one of them. Okay? You could slide the 20 this direction, or you could slide the 14 this direction. It makes absolutely no difference to me. Okay? You should get the same thing regardless. What I see visually right now, I don't know why I see it this way, but what I see is I envision moving the 14. So I'm going to drag this guy this way. Okay? So I'm just going to slide it. I'm going to try to make it parallel to what it was originally, because I don't want to change the direction. That's pretty good. So this is now 14 pounds. And then this 55 also is going to slide, right? So now where is the 55? It's located to the right of this vector. So do y'all agree it's going to be located there? So that means we need to extend this to find our 55. Okay? Now I'm going to mark out the 55 and this vector so I don't get confused with it. I'm now looking at it tip to tail. So I can draw my resultant, which goes from here to here. Okay? So this is my u plus v, or my resultant, and that's what I'm looking for. Okay? Maybe instead of calling it, well, I'm going to leave it u plus v because that's what it's called, but I'm also going to call it x. Now, the 55, remember, is not inside of this triangle. Okay? So if you look at the triangle, it's here. That 55 is outside of the triangle. So we have to use the 55 to help us find the angle. Okay? So if that is 55 degrees, we're going to find this angle by doing 180 minus 55. Okay? So that should be 125. All right, so now we have, just to make sure you're clear, we have a side here, we have an angle here, and then we have the side here. It may be confusing that that side is located inside. I could have written it here, if that seems too confusing that it's inside the triangle. Okay? So if you wanted to kind of redraw it or think about it being redrawn, you could do something like this. That's not exactly perfect, but this is what you're looking for. We have 20, we have 125, and we have 14. And so now, because it's side angle side, we're still going to do law of cosines. So we're going to do x squared equals 20 squared plus 14 squared. Remember, it doesn't matter if you switch the order of those. Addition is commutative. And now let's just type that in. And you get x squared is approximately 917 point blah. And now we're going to square root it. And you should get approximately 30 units. Because it was 30.2, the 2 doesn't make it round up. Now that's all it asked us for, because again, it's kind of hard to tell how the angle opens up and whatnot. So we're just going to find the magnitude. But it is, do y'all see that it's really just the same as these problems up here? It's just a little bit different scenario to start with. But you're still going to slide to make it tip to tail and then do law of cosine. All right, let's do number 14 similarly. Okay, so let's move the other one this time instead of the 48. So we have two forces on an object, 80 degrees is between them. So let's move this one this time. Okay, it's not exactly perfect, but we'll go with it. And now if you're looking at this vector, do y'all agree that 80 is on the right side of it? So the 80 is going to be over here. So I'm going to extend this and I'm going to put 80 degrees in here. All right, now I am going to mark this out. And my resultant is going to go here. Okay. And so if 80 is here, this angle should be 100. And now I can do it. Law of cosines. So x squared equals 48 squared plus 65 squared minus 2 times each of those. And then cosine 100. All right, so we should get about 87. Now that seems kind of large, but let's kind of think about it. 100, the angle that's across from it, is going to be the largest angle in the triangle, and then 87 is bigger than 48 and 65. So that does make sense that it should be the answer. All right, you're going to try the last three. Let me just show that it does not matter how you start these problems. Like, I would just do it the same way every time. Go like this, pick which vector. I showed you that you can move this vector or this vector. It does not matter. Pick which one and kind of stick with it. So like if you want to move this vector, go ahead and slide it and then work your problem. Okay, now I would go ahead and draw it, 70 pounds and 40 pounds and 130. Now, is that very accurate looking? No, because that angle is clearly acute. You can change it if you want, but it's not really necessary. And then drag. Remember, you're going to drag these two numbers together, or you're going to drag these two numbers together. You're always going to be moving that angle when you slide one of the vectors, okay? So notice you're only finding the magnitude for all three of these, and we're rounding to the nearest whole number. So just try it exactly like I did it, and I'll have a form for you to fill out, okay? I hope you guys are doing well. We're getting close to kind of wrapping up, but we're going to do a little bit more with vector word problems and such. All right, y'all have a great day.